Hello, everybody. I want to do an introduction session for the course of wireline technology and well intervention that will be organized later during this month. So we can pass quickly on the subject details that will include the following. First, we have I have to introduce myself quickly. My name is Samer Shukri. I am petroleum engineer since 1995. My nationality is Turkish. I have experienced more than 25 years in the oil and gas sector. I worked for several reputable companies over the world. Here is the summary, and here I am accredited and certified trainer from Scotland, UK, and these are my certificates for training. And I am international accredited IWCF instructor for well intervention. Here also, if anybody wants to contact me, wants to watch my channel on YouTube, this is my name, LinkedIn also, Facebook, email, WhatsApp, also here the telephone, and here are my positions. This is a quick introduction for myself. In this course, we can start with agenda, introduction, well life cycle, introduction to International Well Control Forum, and IWCF certificate and exam, well control calculations, well types, completion principle, classification and types, components, wellhead, production stage, well life gas lift system, reservoir monitoring plan, well intervention principles, well wireline types. We have 3 types: decline, braided line, and E-line. We will go into detail for each type of these. So we can go also to the wireline, proper handling, rig-up of wireline, standard wireline tool string, wireline barriers. Here also wireline tools, connections, wireline tools that are used mainly in the wireline intervention operations. We can see also common applications of slick line, wireline operations before moving coil tubing to the well side, fishing operations. We have also study case for slick line fishing. A braided line uses advantages and disadvantages, E-line applications, perforation, logging, open hole and cased hole. We have also water shutoff, noise log, pressure control equipment for these all 3 types of wireline. We have wireline barriers, primary, secondary, and tertiary. This is the specification of the barrier. We have study case for stuck cable or tools, and at the end we have personal protective equipment, PPE, and then questions and answers. I have questions and answers that can come in the exam, and I included about 20 questions and answers. I gave the right answer for each question, so it is a good practice for all levels, starting from university students, new graduates, all the graduates, the people that have good experience in this in oil and gas industry. Also, everybody is interested, even if he is not expert, but he can go through it and In this case, he can increase his knowledge in this regard, and he can improve himself and can look at this subject more deeply. Let's move on to the introduction. We have to identify or what is the well. It is any hole that can reach from surface to the reservoir that can hold hydrocarbons, oil, gas, and water in the hole in the underground. Mainly, we are looking for oil using oil well, and for gas using gas well. Sometimes we have oil, we have water injector. Sometimes we have gas injector. Sometimes we have WAG, water alternative gas, and other wells also. We have two types of well, exploratory well and production development well. This is for new structure, and this is for development of the structure or the field. All of these depend on the seismic data or satellite data. Here we will focus on the wireline mainly. So wireline history, we can say that this is the wireline unit at the year of 1927. It was very old, and it was mainly focusing on the stick line and formerly known as measuring line. They can run it using to measure the depth of the well. The brothers Schlumberger, two brothers, are considered as the inventors of electric line in this date, 1927. Then they made a company and they started improving it till it is now covering the whole world. And this is the most modern wireline truck that can be used, and also we use the crane with it to rig up and run in hole using pressure control equipment. And this is from the inside work area. Here is the engineer, and here is the winch operator, and here we have the drum wireline storage. Here is the wireline pressure control equipment, Christmas tree. Here we have pressure control equipment. We have primary barrier, which is stuffing box, secondary barrier VOP or wireline valve, tertiary, which is the upper master valve. And here we have hydraulic pumps. We can control the BOP or wireline valve. Here also we have this is a skid mounted wireline that can run in hole and pull out of hole the wireline or stick line. Here also the hydraulic power pack. So it can be used either onshore and offshore. Here is the standard reader. We can pass very quickly on the well life cycle, drilling, completion, production, intervention, then plug and abandonment. We focus on the intervention. Or in different words, we can say design, construct, operate, maintain, and abandonment. Maintain is what is concerning us. Here we start with well construction. It includes drilling, then run completion. Then we can move to the next stage, which is a production. Then maintenance. This is the well intervention stage that includes workover and lifetime extension. Then when we want to close the well, it is abandonment. Here we have, I can give an idea about International Well Control Forum, IWCF certificate that has 5 subjects: completion equipment, completion operation, wireline operation, coil tubing operation, snubbing operation. Here we have mandatory 2 subjects, and here these 3 subjects are optional. We have the 4 levels for this certificate: level 1 awareness, level 2 introductory, level 3 for operators, and level 4 for supervisors. This is IWCF certificate. It is based in Scotland, Aberdeen, Scotland, UK. The other one is based in Texas, in the US. It is called IADC, International IADC. It is called International Authority of Drilling Contractors. That is based in Texas and can be granted for 2 years or so. Here for 2 years for levels 3 and 4, while for level 2 it is for 5 years. For level 1 it is forever. So we have a US certificate, which is IADC, and IWCF, International Well Control Forum. Both, some countries ask for IWCF, some countries ask for IADC. Here, wireline operations, where I show you video about how
like many operations of the oil and gas
rig
service
up
industry,
this
any type of weather for testing, and some for plugging off zones in the well.
wireline
Bruce threaded
rig up.
lifts the unit into place where it's
This is the
secured to the top of the
lubricator,
wellhead.
BOP,
The wellhead is open and the wire line is run into the
and
well.
running
At
the
this
slick
site,
line.
near service work. Slick wireline operators are
Then we
sometimes
can
part
pressure
detective
test
and part
the
fisherman, since they have to
lubricator.
figure out how to grab something from the petroleum services industry.
Here, this is the river. Wireline operation. Here we have the calculations for well control. These formulae can be memorized by heart. Hydrostatic pressure equals to vertical depth times density times constant. Here also, for if we have hydrostatic pressure for oil and gas, we can add hydrostatic pressure for oil to hydrostatic pressure for gas. Here also, if we have gas column, we can obtain the correction factor for the gas times closed-end tubing head pressure. For bottom hole pressure, it is hydrostatic pressure plus closed-end tubing head pressure. Reservoir pressure equals bottom hole pressure. We have specific gravity if the API is given to us. We have also specific gravity, oil density divided by water density, pressure gradient. Also, this is the formula. Time to pump this also. We have the types of the wells: exploration and the production. We have a vertical, horizontal, and deviated. The types as per the production phase: oil producer, gas producer, water injector, gas injector, well injector, and water supply well, and at the end, water disposal well. Completion, this is run in the well to protect the casing. We have 3 types as the classification of the completion. It is open hole completion. Here we have cased perforated hole completion, and here we have multiple zone completion. We have upper zone, lower zone. Here also we have completion types for natural injector wells. We have single completion, single selective, dual completion, dual selective. You see here, single completion, single selective, dual completion. Here we have a single slim hole. We have vertical well and horizontal well. Here we have typical completion components from the Christmas tree till the wireline entry guard. Each one, we have to know them. Sliding side door, gas lift mandrel, sub-Saharan valve, F nipple, R nipple, wireline entry guide, perforated pop joint, packer, casing, tubing hanger, outlet valves. For the Christmas tree also, we will see the valves that we can control the flow of the well using them. Here also the same completion components. We have tubing hanger. It is the top part of the completion that can hold the tubing weight and isolate tubing from the annulus, also sub-Saharan valve. We have two types, surface controlled and subsurface controlled. It can close in case of an emergency to make the well safe. This is the sub-Saharan valve. We have wireline retrievable and tubing retrievable. So we can, wireline retrievable can be set in the well for 12 to 24 months. Then we can retrieve it and do maintenance. While for tubing retrievable, it will stay in the well for 20 years, 30 years without pulling it, except if it is failed, then we can move work over and replace it after pulling the completion. Here is the sub-surface safety valve. We call it downhole safety valve, surge control sub-surface safety valve, surface safety valve, tubing retrievable. So different names for the same item. Here is the flapper here. And here, if the flapper is open like this, then the safety valve is open. If the flapper is closed like this, then the safety valve is closed. Production string, through it we can produce from the reservoir to the surface or vice versa. If the well is a water injector or gas injector, we have different types, different colors for the coupling. In this case, we can choose the suitable completion type. Protection packer, it can isolate the casing from the tubing, and in this case, we protect the casing over the lifetime. We have two types, permanent packer and retrievable packer. Each one has packing and slips. It could be a single packer or a dual packer. We have landing nipples. We set inside them the flow control devices. We have no-go nipples, selective landing nipples. This is no-go nipple. It is located at the last item below the packer. And above it, we install the selective landing nipples. We have also ported or safety valve nipple. Circulation devices, we have two types, sliding side door and side pocket mandrel. This is side pocket mandrel. We have a sleeve here. It has holes and the fixed holes here. When we move this sleeve up, then it will be like this. Then we can do circulation, either reverse circulation from annulus to tubing or from tubing to annulus. This is forward circulation. So this is closed, this is open, and this is the SSD, sliding side door. We can also set circulation valve inside the side pocket mandrel in a gas lift completion. Then we can inject gas in the annulus, then produce gas and oil from the tubing. We run it and pull it using the kickover tool, this one. And we have different types of the gas lift valves. We have orifice, we have injector valve, injection valve, we have circulation valve, dummy valve, dump kill valve, so different types. For flow coupling and blast joint, these are run to reduce or prevent at least the erosion due to flow coupling due to turbulent flow inside the tubing, and this is blast joint to protect it from the erosion that is resulting from the flowing of hydrocarbons from the reservoir to the completion. And it has bigger wall thickness than the normal tube. Here is the flow coupling. We can move also to the polished bore receptacle, PBR, that can contain the movement of the tubing. If it is hot or cold, also travel joint. You see different types, expansion joint, and here is PBR. Wireline entry guide, it is located at the last end of the completion. When the wireline tool string gets out of the completion, we have to run it again inside the tubing safely. So we install wireline entry guide. We have two types, bell guide and a new shoe guide. New shoe. Wellhead, this we can control the flow of the well, inject or produce, pump, do circulation, do stimulation, nitrogen kick-off, all of these using these valves. API connection, it has a 3,000, 5,000 PSI, 2,000, 3,000, 5,000 PSI maximum working pressure. Here, this is conventional. We sometimes find 10,000, 15,000, it depends, and it has different types. This is conventional, this is monobore completion, this is one block, while these are different pieces of the valves, and we can connect them using the API planes. And here, this is the production. This is the surface casing, intermediate casing, and surface casing. And we have casing, head housing, and casing hanger for each stage of them. And then we have tubing hanger, and below it there will be the completion, and above it there is Christmas tree. Here is the Christmas tree monobore. This is gas well. Here is, you see it is big. Production stage, we produce the well for 20 years, 30 years, whatever. Then we can do the maintenance or intervention from the wellhead here to the station. We can then separate oil from the gas and water. Gas lift system, we can take an idea about it, how can we produce from inject gas from the annulus and produce from the tubing. This valve will open first, then this valve, and so on. So we can reduce the hydrostatic pressure that is applied on the reservoir and produce it to the surface. Here are the valves types: gas lift valve or orifice valve. Here dummy valve. We have dump kill valve. We have chemical injection valve. We have circulation valve. So all of these can be run using side pocket mandrel. This one, and it has packing, two sets of packing. Here the injection, and here we have the pillow. Injection, it is calibrated using nitrogen. We can use using wireline reservoir monitoring plant. We run these surveys: BHCIB, VHFP, PFO, PBU, interference test, integrity test, capacity test, and modified isochronal test. All of these just to monitor the reservoir, and we can keep the reservoir under control and make everything updated for us. If we need to increase support the reservoir pressure, we can do it based on these surveys. You see here, the SCIP, we can obtain the reservoir pressure. We stop for 2 hours. After closing the well, we run gauge, memory gauge, and in this case, we can measure the reservoir pressure. It is called bottom hole closed-in pressure survey. Here we have modified isopropyl test. This is done for gas well. So we open the well at 25% of maximum capacity, then close it 12 hours, 12 hours, then at 50%, then 75%, then here 100%, fully open. So open for 12 hours, close for 12 hours, 12 hours, 12 hours, then here 24 hours, then close it for 48 hours. Then we can pull or retrieve the memory gauge, download the data, and then interpret it. Here, if we don't want to close the well, we have nearby observer well or observation well. We can run the gauge cutter here and measure the reservoir pressure at the same depth of this. This is the active well. If we close it, it might be dead, or it will not flow again. In this case, we go to the adjacent well, which is observer well, and measure the reservoir pressure. Well, intervention, we have 9 main types of the intervention operations. But here we mentioned the following: wire line, that includes stick line, braided line, electric line. It was invented in 1927. Then electric line tractor, it was introduced in 2003. Then coil tubing in 1962, hydraulic workover 1929. This is snubbing, hydraulic workover. Here, if we go into detail, we can see that the intervention methods are 9 types, and we have the definition of each one. We can start with pumping, wellhead maintenance, and the Christmas tree, slick line, braided line. We have electric line also is included with this one, with the braided line. It is very similar. Coil tubing, snubbing, workover, subsea well intervention. You see it. This is the these are the types of wire line. We have stick line, a braided line. This is a braided line, and we have electric line. In the middle, we have electric line conductors. They can move the signal from surface to the downhole, and we can monitor what is going downhole. Here is the slick line, this one. Here is the braided line. We have 2 main types, and electric line. And each one has its own rig up and pressure control equipment. Here is the slick line. We have 2 main types, depending on the OD. We have 2 ODs, 0.108 and 0.125 inch. We have 2 types, carbon steel and stainless steel. Carbon steel, it has higher tension, but it can be used till H2S 30 ppm. After that, it will not be used anymore. We have then to use the stainless steel. Stainless steel is more resistant to the corrosion of the H2S, of CO2, or any similar environment, but it has less tensile tension. So every type has its own uses. A braided line, we have 2 types, conventional, like this, opposite direction, and diaphragm. Diaphragm has a high breaking strength, smooth External, you see one direction, the red one and yellow one. The middle one will be the conductor. We have also the third type is E-line, electric line. We have monoconductor, this one, and multi-conductor. We can move the electrical signal from surface to the downhole. We have sizes. Here we have 16 strands in braided line. Here in conventional, in diaphragm, we have 19 strands. In electric line, monoconductor, one conductor here. The size of the cable is 316 or more, which is 7/32. Multiple conductor, we have cable 3/4, 5/16, 7/16, and 1 and 3/4. Slick line wire line, we have two sizes, 0.108 inch and 0.125. The material is this carbon steel, and this is stainless steel. Breaking strain, you see carbon steel has a higher breaking strain than stainless steel. But here, remarks, we have poor corrosive resistance, while here it has to work in the sour gas applications. 0.125, also the same carbon steel and stainless steel. You see carbon steel has higher breaking strain than stainless steel. Also, poor corrosive resistance and sour gas applications. Braided line, we have these diameters, 7/32 and 5/16 inch. We have two types, conventional and diaphragm. These are breaking strain and remarks, diaphragm considerably stronger. Conventional and diaphragm also, these are the breaking strains. We have a very high breaking force, gives the operator better margins when carrying out fishing operations. So with this one, we can do fishing operation and we can do swabbing to lift the well without using nitrogen lift. Let's move on to electric line wire line. We have a nominal diameter 7/32 poly cable and 5/16 inch poly cable. It has this one has monoconductor, electric line monoconductor, widely used for electric line operations. Breaking strain typically 5,200 pounds. Remarks, cable type will depend on well conditions and operations conducted. Here for this poly cable, commonly used for logging and perforating. Typically, breaking strain is 11,000 pounds. Remarks, Cerberus modeling will determine wire selection. The stick line, this is the stick line. It is stainless steel. We can do most of our operations, such as gauge cutter, setting and pulling plugs. We have also set and pull sub-saharan safety valve, set and pull the memory gauge, open and close SSD, set and retrieve gas lift valves. Stick line is a very simple. It has two ODs, 0.108 and 0.125 inch. This one is used in normal operation by running wireline tool string on this wire. If in the oil and gas industry, the term wireline is usually referring to the use of multi-conductor, single conductor, or stick line. So three types: slick line, single conductor, and multi-conductor cable, or wire line as a conveyance For what? For the acquisition of subsurface. If we want to collect data from the downhole, we can run the wireline. So slick line, we have these details, wireline tools, and we have stainless steel and carbon steel. Carbon steel is used till H2S 30 ppm, while H2S environment, we have stainless steel. This type is improved flow steel IPS, which has many advantages. It has high tensile strength, low cost, good ductility. This is improved flow steel or stainless steel. Good ductility can be used in sweet wells and with H2S up to 30 ppm. This is carbon steel or improved flow steel, which has these advantages. Stainless steel, we have to use it in the sour wells, but it is weaker than carbon steel. It has more tension that can be applied on the wire. There are different types of stainless steel, SOPA 70, SOPA 75, and SOPA 80. Stainless steel is corrosion resistant. Wireline proper handling to reduce bending stresses. We have, after when we first run the wireline in the hole, we have to put the lubricant on the wire to reduce the friction. We have from time to time to cut about 50 feet from the wire to change the weak point. When jarring operation, it is advised to stop for a short period to cool down the wire. The wire will become hot, so we can stop and make it cold. We may need to move the wire also for many feet up, front or right or left, just to change the weak point and reduce the stress during during jarring for long time. Here we have stuffing box, and this is the heavily. When we want to spool on the wire line, it will be like this, while this one is incorrect. So spooling wire line properly like this, avoid kinking of the wire. It should not be kinked because it will be as a weak point. Avoid the wire from contacting with metal. It should be away from the metal. Stuffing box heavily OD. This one should be for a slick line. We have the OD of this heavily 120 times wire line or slick line OD. For braided line, we have it 64 times braided line OD. Wireline rig up also we have to look at it. This is for Al Masuri in Abu Dhabi. So this is the rig up, the toolbox store. This is the stuffing box, BOP, rig up, then pressure test. This is Mansouri, very famous in Abu Dhabi. Let's move on to the advantages of using wireline over coil tubing. These low-cost, low crew members, easy to move and transport. Also, disadvantages: we cannot pump fluids through it, we cannot rotate it, we cannot open and close SSD in the horizontal wells and the highly deviated wells more than 70 degree. Here is the rig up. Here we have bending cycles in wireline. We can see the points of them also in the photograph. High poly angle. We have three cases. High poly angle 90, more than 90, less than 90 degree. Standard wireline tool string. We have rope socket, stem bar, mechanical jar, and knuckle joint. Then at the end we have wireline running or pulling tool. This is the standard tool string, wireline tool string. This is the standard rig up, typical for braided line, and this is a stick line, stuffing box, and this is E-line and braided line. This is for braided line and electric line, grease injection head. And we have a lubricator, we have flow tubes here, we have a stuffing box, line wiper, chemical injection sub, tool catcher, tool trap. You see tool trap, this one, quick test sub, lubricator sections. It should include the maximum the length of the tool string in the well. We have also here either single or dual VOP. Here either it should be minimum 2, which is dual, or double 4 rounds. Here also the rig up. This is standard wireline equipment rig up. This is the platform of the Schlumberger. It is about 38 feet because we have to run the tool string inside it. Examples for barriers: we have stuffing box, grease injection head, VOPs. The connection between them, we have quick union for wellhead equipment. We have Bowen and Otis. Bowen has 90 degrees shoulder, this one in the collar, and this Otis type has 45 degrees. Here also we have O-ring. Here is the pin, and here is the box. Here we have 3 types: second-order threads like this one, UN threads, and quick union threads. These are the tools, plugs, the shifting tools that can be run. We can look at them one by one. Fishing tools. The most common applications for wireline can tag TD, do gauge cutter, baling, shifting sleeves, setting and pulling plugs and shocks, setting and pulling gas lift valves, running tailpipes. Also, we have bottom hole pressure and temperature surveys, spinner surveys, PLT, production logging tool, TDT, thermal decay time. We have Kinley perforator if we need to perforate the tubing. We have sand line cutter, caliper, running production logging tools, and then fishing operations. We go ahead with paraffin, wax, cutting, chipping ice, lubricating long assemblies in and out of the hole. Bottom hole sampling, detonate of perforating guns with wireline using mechanical bar drop, firing head, shoot and drop. Then detect fluid interfaces. If we have gas, oil, water in the well, we can know the interfaces between them, gas, oil, water. Depending on the weight of the tool string, if the weight drops, then we have this one which is called the interface, gas-oil contact or oil-water contact. Then we can set and pull subsurface valve for routine redress, and before running the tools for well intervention operations. So subsurface valve is a vital item. While operations before moving coil tubing to the west side, what can we do? We can do drift run, pull well and retrieve subsurface safety valve. In some cases, we have to run wire line and measure the reservoir pressure and collect data for killing program. It is sometimes required to open and close SSD in horizontal and highly deviated wells. Also, it may be required to set wireline plug to isolate the formation. Fishing operations, this is a very interesting subject. Fishing usually refers to attempting to retrieve lost tools or wire or other debris that was not intended to restrict the flow, disrupt the well operations. So this is a very interesting subject. We can move on to the braided line. It is used for swabbing and fishing, also the stick line and tourist string. Braided line types, we have conventional and diform, depending on the wrapping direction of the strands. We saw it just a while. Advantages, it has it is made of synthetic materials, hard materials, and offers superior strength while maintaining a small diameter. Here we may many braided lines are difficult to break. This is advantage. A braided line can have much real life. This one properly spooled and maintained while using. Disadvantages, when it is snagged, it is sometimes becomes very difficult to break. So snagging it or changing the shape or the material of it, it will make it easy, difficult. A braided line is generally more expensive than monofilament line. A braided line can put more stress on the parts, rods, and line guides. Also, these advantages, braided line may not be the best choice when fishing in clear water. If backlashed, braided line can sometimes be very difficult to untangle. Most braided lines require much sharper instruments to cut it properly and require a small tag to protect from slippage. Electric line, we run logging, we do perforation and water shuttle. We have two types of logging. We have cased hole logging and open hole logging. This is open hole. We have resistivity, acoustic log, nuclear log, nuclear magnetic resonance, NMR log, mud logging, sonic logging, and specific logs. In the cased hole log, we have temperature log, radioactive tracer log, noise log, diverting spinner flow meter, and continuous and full bore spinner flow meters. Noise log, we have, this is an example. It needs 2 days to perform this survey. Here, the perforation, we have to perforate the formation and produce or inject into it. The major purpose of perforation is to provide communication between the reservoir and the bottom hole or the well bore, here between the well bore and the reservoir. To create a perforation, a perforating gun is used to shoot a hole through the casing cement. So run in hole with electric line to the string, do correlation, discover the depth, then he has to do this perforation. The major purpose of perforation, we said that so perforation gun is used to shoot a hole through the casing and cement. Oil well perforation, we have overbalanced perforation and underbalanced perforation. These are the guns. We have three types: through casing perforation here, casing gun, and through tubing perforation, this one inside the tubing, and we have the third type is tubing conveyed perforation, TCP, either shoot and drop or shoot and pull out of hole. Here are the pressure control equipment. Slickline pressure control equipment includes stuffing box, chemical injection sub, hydraulic tool catcher, lubricator section, hydraulic tool trap if required, quick test sub, wire line, BOPs with blind drums, riser and BOP, riser and pump in T, and the last we have Christmas tree wellhead adapter or crossover. Braided line pressure control equipment. It is very similar to slick line with some change. Here in slick line we have stuffing box, while in braided line and electric line we have grease injection head. Here also. This is the rig up of slick line. This is the rig up of this is the pressure control equipment for braided line and electric line, grease injection head. We inject grease from the bottom section of the flow tube, and the return will come from the upper section. We have a line wiper and stuffing box. Here we have stuffing box, lubricator, VOP, and tree flint. The stuffing box is specially designed to seal around the wire, so it has leak type, zero leak. This one, because it is a primary barrier and closed during the whole operation. So if it is leaking, then we have to, or before we wait to get leak from here, we have to make sure that the packing is suitable for the operation. This allows wireline operation to be carried out under pressure. The stuffing box can be operated either manually or hydraulically without part modifications. So here we have this is the packing nut. Either we apply hydraulic pressure on it here to seal around the wire using the packing of the stuffing box. This is hydraulically, or manually somebody will climb up and this is all the type and tighten the packing nut and achieve the seal. But the most stuffing box in use is the hydraulically operated. This is using the hand pump. This is chemical injection sub. We can take them one by one. Hydraulic tool catcher, wire line lubricator sections. We have hydraulic tool trap, quick test sub. This one, we can test the lubricator only once. here are the rams of the BOP. Here it is a blind ram. Here we have normal. This is normal and normal valve rams. So here the blind, you see, this is blind. This is the wire guide. So if we change the wire, then the ram and guide will be changed out also. Here is the single BOP or wireline valve, the ram here and ram guide. Here we have the types, the parts of the BOP. Here we inject hydraulic oil in this chamber to close it. When we want to open it, we pump here hydraulic oil. We have pump in T or sub. We have a wellhead adapter and types. We can talk about it. We have this is a stuffing box for braided line, hydraulic line wiper to clean the line. This is. We have grease injection head also, or flow tube. We can see how many flow tubes. Here is the grease injection system, pump here, and the return will be here to the waste drum. Here there should be clearance between the cable and the internal side of the flow tube between 0.002 to 0.008 inch. And the number of the flow tubes will depend on the wellhead pressure. So every 1,500 psi will need one flow tube. So as the wellhead pressure increases, the number of flow tubes will increase. We have a ball check valve. This one, if the cable is cut and blown out of the stuffing of the grease injection head, then this ball will set here due to wellhead pressure and will close the flow path. Here we talked about the flow tube and ID. Reasons for braided line, grease seal. We have these reasons. To prevent the leak from grease injection head, we do these steps. Here braided line, it should be dual, two rams. The upper one is normal and the lower one is braided. So between them, we inject grease. So the upper one, normal, will hold the well pressure, but this one, inverted ram, will hold the grease pressure. So the grease pressure will be here, injected here, it will go to here and will go here. This is the dual BOP for braided line, similar to single, but we have inverted. You see, this is normal, this one, and this is inverted. So it will be like this, the lower one. The upper one will be like this. Or the opposite, yes. This is the upper one, this is normal. So the pressure will come from the bottom and will push it to achieve the seal, like this one, while the lower one will take the, like this one, this is where the grease injection head will be injected in the middle between the two rams, and it will push on it like this and achieve the seal. We have this type double BOP. So we have here normal ram, inverted ram, normal ram, inverted ram. Here is triple BOP. Here shear seal BOP, tertiary barrier. Here we can see the shear seal ram. This is typical wireline pressure control equipment rig up also. BOP pressure test. How can we do pressure test? BOP should be function tested and pressure tested after rig up and before any operation. We do low pressure test and high pressure test, and we will know the details of this. Here, pressure test of wireline BOP body. As per API guidelines, we have this one depending on the maximum working pressure. Agrees require cases that require to close the BOP. We have three main cases. We can mention them and go into details. We can talk about explosive decompression of elastomers. Also, what is the definition? Why we face it like this? The rubber will be damaged. Here we have open and close procedures during wireline operations. How can we open and close these valves of the Christmas tree? You see them. Open upper master valve, then swap valve to avoid causing damage to the upper master valve. So open this one, then open this one. And when we open this one, we have to wait to equalize the pressure in the lubricator above and below the valve. When we want to close, we close this first, then close this first, second. Lubricator sections and connections. We will talk about lubricator. Here we have Bowen 90 degrees the sealing area, and Otis 45 degrees the sealing area. This one, sealing area, Bowen 90 degrees, and here Otis 45 degrees. Pressure test of the lubricator. How can we pressure test it? Lubricator bleed off also. A pressure equalization. There is equalizing valve on each BOP. We can equalize the pressure between above and below it. API flames also. What are the types? What does it mean? If they give us the type, the number, working pressure, ID, and the flange ring gasket. We have three. Flange can be described by three items. This is the ID of the flange, working pressure, and the flange ring gasket. This one, you see it, the ID, OD, and here the flange. This is the flange. We can connect it to the wellhead. And here is the top face, here is the bottom face. Examples of flanges, you see one of them. We can take these examples. This is the ID. This is the maximum working pressure. You see, and here we can see weld flange, weld neck flange. Ring joint gasket also. We have three main types, RRX, BX. It is depending on the pressure that can work in it, and each size. We have mainly 5 types, but we focus on 3 types. Material of ring gasket. This is the metal, mainly soft iron, low carbon steel, stainless steel. Here we have, this is R ring gasket, this is RX, and this is BX. Wireline emergency procedures, we can go through them one by one. Leak in stuffing box, leak in connection between lubricator sections, if BOP is not holding pressure, if wireline is cut and ejected out of the lubricator. A study case for stick line fishing. Fishing is very interesting. You can go through it. Study case also for stuck cable or tools, personal protective equipment, PPE, that is used during the work. Here we have questions and answers for wireline mainly. So we can go through them one by one, and you can see and discover some special cases and the classification of barriers, primary, secondary, tertiary, and so on. So you can go through them and see what is there. These are real questions that come in the exam. So 19 questions and answers. This is the end, and if there is any question can be asked by attendees, it will be welcome. I hope that this 1 hour we can cover our session, our coming course. We can show you many videos. We can go to a whiteboard. We can go to interaction. So the course will take 3 days. During these 3 days, you will be expert in wireline, about wireline intervention, well intervention, wireline technology, all of this. So good luck, and I hope that I gave you enough information to decide whether to join us in the next course or not. Thank you, everybody, and enjoy. I hope that you will go to my YouTube channel, do subscribe and like to allow you to receive any new video that I can upload it into the YouTube. Thank you again, and good luck.